Hi, my name is Elton, and today I'll be talking about the topic of dealing with an unbalanced data set. What is unbalanced data? Unbalanced data is a problem affecting machine learning applications. Data sets that contain disproportionate classes is called unbalanced data. Some data sets are hard to obtain, which leads to unbalanced data. This can be due to it being expensive or hard to get, or that the data set is just inherently skewed. Why is unbalanced data a problem? Unbalanced data leads to training models spending significant time on one class and inadequate time on another class. This can lead to something called an accuracy paradox. This is because the neural network is more focused on the majority class and only spits out results based on the majority class. Here you can see two datasets, one balanced dataset, which is male and female, and an unbalanced dataset, which is normal transactions versus fraudulent transactions. This will produce inaccurate results as the unbalanced data set will always have 99% accuracy because it will not track the fraudulent results. Here's an example data set on the spruce tree timber quality. We can see on the right of the figure the poor and excellent data is lower than the good data. This is unbalanced, and we can see in the next slide here. You can see that the confusion matrix shows 77% accuracy, but this is false as you can see there's no detections of the bad data, even though there's 150 samples. We can test this by using this code on the left here, which tests the accuracy by dividing the results into tree and testing the individual classes. We can see that it produces a result of only 43% accuracy. On the bottom here is code to show the different percentages of the poor, good, and excellent quality. We can see that the bad data has 0% accuracy, but the good data has 95% accuracy, as well as the excellent data having only 34% accuracy. This is because of the unbalanced data. And here are some methods we can use to reduce or solve unbalanced data issues. We can use interpolation or to synthesize new data, improve quality of data set, such as gathering more data. We can resample data set to undersample or oversample, weighting classes differently, such as underweighting and overweighting. And then we have these advanced methods, such as variational autoencoder, which is a deep learning technique to interpolate data by taking data as inputs and discovering latent state representations of that data. We also have SMOTE, or synthetic minority oversampling technique. This is a great solution to solving unbalanced data problems. SMOTE works by getting random samples in the dataset, then finding its nearest neighbor to create a new data point between the sample and its neighbor. We have GAN, which is Generative Adversarial Network, which is a machine learning framework to generate new data with the same characteristics as the training dataset. GAN uses two neural networks, a generator and discriminator, to create data that the framework is unable to distinguish between the original and the synthesized data. I will now talk about two different methods of solving. We have undersampling and oversampling. Here we can see that the original dataset is unbalanced. We can undersample it to reduce the majority class so that it is in line with the minority class, or we can oversample by increasing the minority class to match that of the majority class. Here is a simple solution, which is to undersample. As you can see on the right, we have the poor, good, and excellent all undersampled to 156 points, which is equal to the poor data. This produces a result of 65%, which is lower than that of the previous neural network, but this is in turn more accurate. As you can see that all three data sets, all three classes are being detected properly. Here is the previous code that I've run, and we can see that the percentages of each class is being recognized normally, and we have a general accuracy of around 65%. Here I have another method, which is data synthesis or augmentation. This creates new suitable data where actual data is hard to obtain, and dependent implementation can be simple or complex. Here I have a simple solution to generate new data or augment the data to produce enough poor and excellent data other than just oversampling. In the code here, I have added percent noise to distinguish between different data points. When I use this to train the neural network, we can see it produces an accuracy of around almost 70%, which is really good compared to the previous simplified neural network. We can see here the accuracy of each of the classes, which is higher than that of the previous neural network, and a total accuracy of around 68%. This solution has some problems. As we can see, the excellent data is slightly more overfitted compared to the good and bad data. In conclusion, unbalanced data is a machine learning problem that can be solved with different methods, and each solution has their own pros and cons, such as overfitting. Here on the right is an image of a dominance dataset, which is a really good dataset, where every single data point is of high quality, and this can lead to high accuracy within the neural network. Thank you for listening to my video.